Welcome to the Explainer. So, if you've ever sat back and wondered exactly how the universe enforces its ultimate speed limit without somehow breaking the fundamental geometry of space, well, you are in exactly the right place. Today, we're diving into some truly mind-bending physics, and we're going to break it all down step by step.
To do this, we're exploring a deeply fascinating approach straight out of Chapter 18 of the book Newton and Relativity by Sester, Clemente, and Korff. Now, here's what makes their framework so incredibly exciting. The relativistic formulas we're looking at were derived completely without using the postulate of the constancy of the speed of light and without using Lorentz transformations, not directly, not indirectly, nothing. Instead, we're relying entirely on the pure, fundamental laws of energy conservation. It's a completely fresh, almost mechanical way to look at relativity, and we're going to piece this elegant puzzle together right now.
Let's kick things off with a classic astronomical paradox. Imagine you're an observer peering through a telescope out into the deep cosmos. You spot a distant galaxy, and it's moving away from you at 80% the speed of light, so 0.8 c. Now picture a star inside that very same galaxy. That star is also moving at 0.8 c, but it's traveling completely orthogonally, perpendicular to the galaxy's path. Because of that angle, the combined movement, or resultant vector, aims straight down your line of sight. So the big question is, how fast is that star actually moving away from you? Well, this perfectly illustrates a massive, catastrophic problem we hit if we try to just use classical mechanics. Think back to high school geometry for a second. You'd probably just use the Pythagorean theorem, right? A squared plus b squared equals c squared. Simple enough. But if we square 0.8 c and add it to another squared 0.8 c, the classical math spits out a resultant speed of 1.13 c. Wait, 1.13 c? That exceeds the speed of light. And physically, that demands the impossible consequence that the star would become completely invisible to you, the observer, because its light could literally never reach us. So for sure, classical geometry is utterly failing us here. To solve this mystery, and remember, we are bound by our unconventional Lorentz-free constraints, we have to radically shift our perspective. Let's set up a really simple, clean thought experiment. Imagine a central collision between two electrons. They are moving directly toward each other at the exact same velocity, let's call it Vx. When they crash, boom, they form a brand new, single, stationary particle with a specific rest mass, which we'll just label m0. It's a perfectly symmetrical head-on collision.
Okay, now let's introduce a crucial perspective shift. We are going to look at that exact same electron crash, but from two entirely different viewpoints. First, we've got a stationary observer. Let's call them observer O. To them, the new particle gets created and just sits there, perfectly at rest right at the origin. But then we introduce observer O'. This observer is moving upwards, perfectly orthogonally, along the y-axis. To this moving observer, that newly formed particle isn't sitting still at all. It actually appears to be drifting downwards, away from them along the y-axis at their exact speed, v sub y. It's the exact same physical event, just experienced through two completely different geometrical lenses.
Now here is where the absolute magic happens. By applying the unshakable law of conservation of energy to both of these observers, we can construct a mathematical bridge that locks those horizontal and vertical velocities together. See, observer O has an energy equation based on rest mass, while observer O' has one based on moving mass. But because energy absolutely must be conserved across both frames, we can literally substitute observer O's equation straight into observer O''s equation. It's so beautifully simple. We are using the pure, raw physics of energy to force the geometry of space to show its hand.
And the mathematical payoff? It is absolutely stunning. When you substitute those energy equations and simplify them, the mass terms perfectly cancel each other out. They literally just vanish, leaving us with this incredibly pure velocity relationship. If you look at the resulting formula, you've got your standard, familiar, classical Pythagorean base, Vx squared plus Vy squared. But now, attached to it is a brand new, highly distinct subtraction mechanism. It's a relativistic correction factor, and it was derived entirely from the conservation of energy. When we actually map this new equation out, things get really clear. At low, everyday speeds, that relativistic correction factor is practically zero. It perfectly matches our classical Pythagorean expectations. Honestly, you wouldn't even notice it driving your car down the highway. But as those velocities creep up toward the speed of light, that subtraction term grows exponentially. It aggressively penalizes the sum, actively fighting against those high-speed additions to strictly enforce the cosmic speed limit. It's essentially nature's own built-in braking system.
So, let's bring this all the way back to our astronomical paradox. The galaxy and the star. Remember how classical math gave us that totally impossible 1.13 c? Well, if we take those same 0.8c velocities and plug them into our newly derived formula, complete with our new subtraction factor, it mathematically resolves the star's actual speed to about 0.933c. Just like that, the paradox vanishes. This completely proves that the cosmic limit is beautifully preserved, the math works out flawlessly, and best of all, our distant star remains totally visible in the sky.
Now, let's take things up a notch and see how this scales into real-world astrophysics. Because, let's face it, the universe isn't a flat piece of paper, right? It operates in full 3D space, meaning we need a third orthogonal velocity vector, the z-axis. To compose 3 orthogonal velocities, we just take the 2D resultant velocity we just calculated and treat that as our new unified baseline. Then, we simply compose it orthogonally with our third velocity.
This approach gives us this brilliant modular architecture to play with. By substituting the 2D formula into a third composition, our initial logic just cascades naturally into a much more robust, interlocking 3D equation. It branches out into this incredibly complex web of classical additions, followed by multiple relativistic subtractions, and it even has a final addition term at the very end, just to balance the whole thing out. Sure, it looks like a beast of an equation, but underneath it all, it is built entirely on the simple, repeatable logic of energy conservation.
And the best part? This perfectly confirms our theory across all dimensions. When we stress test the limits of this equation, it holds up. If you set one of the velocities to 0, the 3D equation collapses perfectly right back into our 2D formula. If you keep the speeds low, it acts as like standard 3D Pythagorean addition. But the real kicker is this. Even if multiple input velocities perfectly match the speed of light, the expanded formula's complex web of subtractions balances perfectly to ensure the final resultant velocity never ever exceeds c. The math is literally bulletproof. To really hammer this home, the authors used a formal mathematical proof by contradiction, a reductio ad absurdum. Basically, they say, okay, let's pretend just for a second that the final velocity could somehow exceed the speed of light. Let's assume the sum is greater than 1, where 1 equals light speed. Well, as you factor and reorganize the terms, the math completely breaks down into total absurdity. You actually end up with a statement claiming that the product of two positive numbers is somehow less than 0. Since the inputs obviously cannot exceed 1, multiplying two positive numbers can never give you a negative. Therefore, exceeding the speed of light isn't just physically impossible, it is a mathematical absurdity.
It's just wild to look back at the journey we just took. We went from an impossible astronomical paradox where stars literally disappear, all the way to discovering a universal scaling mechanism. And the absolute coolest part of this entire framework from Chapter 18 is that this relativistic subtraction factor isn't just some arbitrary math trick to make the numbers work. It is rooted completely and entirely in the conservation of energy. Because energy cannot be created or destroyed, it provides a mathematical guarantee that the very fabric of space and velocity has to flex dynamically.
Which brings us to the end of our explainer today, and I really want to leave you with this provocative thought to chew on. If we don't actually need the postulate of the speed of light to prove these limits, but instead only need the basic conservation of mass and energy, does the fundamental law of energy conservation intrinsically flex the very geometry of space and velocity itself? Is energy actually the ultimate architect, tirelessly working behind the scenes to protect the cosmic speed limit across any number of dimensions? It's a pretty incredible way to view the mechanics of our universe. Thank you so much for joining me today. I really hope this helped make these complex ideas click for you. Keep questioning and keep learning.